Hello, can you hear me? Okay.
ಅದು ಗೊತ್ತು, ಅದನ್ನ ಮಾಡ್ತೀವಿ. ಆಲ್ಟ್ ಆಗ್ಬಿಡ್ತಿ. ಹಾ ಹಾ Good evening. A very warm welcome to all the participants after lunch. We have the next speaker, Dr. Vivek R. who has been an associate professor in the Department of Civil Engineering in our very own college, Ramaiah College. To brief about him, Dr. Vivek Ramadas is presently working as an associate professor in the Department of Civil Engineering, RIT. Previously, he had worked as a PG professor in highway technology in Dayanand Sagar College of Engineering. He did his BTech from TKM College of Engineering, Kollam, MTech from College of Engineering, Trivandrum, and PhD from IIT, Roorkee. He has worked as an engineer for 3 years in Consulting Services Private Limited. He has published about 75 papers in various reputed journals and conferences. He has guided nearly 58 MTech theses and currently guiding 4 PhD theses. He is a reviewer of various international journals and conferences. He is also certified in 5 MOOC MOOCs course conducted by various IITs, and his area of specialization is traffic engineering. We welcome Dr. Vivek R. to take over the talk. Thank you, sir.
Thank you, Niranjan, for these nice words. So, being a coordinator, when we started this program, so I was little confused because what topic I'll take, I have just called various resource persons and they have identified their areas. Then I was little confused. So what topic I take? My area was mainly on traffic. So I thought that I will take some topic with respect to intersection and present in that. Then again, I'll go through various other topics. And I found out that this topic, what I have selected, has not done much research in our country. That is transit capacity. I think this topic, even in PG level, has not been taught in many of the colleges. it has been taught as mainly public transportation that mainly depends on bus rapid transit and various classes of that. So with this background, what I have decided is this topic will give lot of ideas within the participants for developing a transit capacity manual in our country. Now, if you take other uh, specialization within transportation, that is payments, planning, and traffic, a lot of research has been done. Payments, you can see that IRC codes has been updated. Traffic, you can see Indo HCM has been recently developed. But with respect to transit capacity, that is public transportation, how to evaluate this? That research is still in the kid state. Now, so I have selected this topic, that is transit capacity. So transit, as you know, is a process of movement from one point to another. And here it will be the movement of passengers and mainly the goods. But with respect to public transportation, this is mainly deals with passenger transportation. And capacity, as you know, is a critical word which tells that the maximum value. So in this case, for a given condition, what is the maximum number of passengers which can be transferred through a given point? So what I thought is I'll just go through the various researches and various capacity manuals which has been developed in US. So what are the provisions what they have given in there? You can take away some of those parameters from that and use it in your research or studies. Okay. So before getting to my topic, first I acknowledge most of my presentation materials has been taken from this. And some of the Google images also I taken, and some of the definitions I taken from Wikipedia also. And I also acknowledge that this data will be used only for academic purposes. So my sequence of presentation is are shown here. That is, I'll start with different types of transit modes which is available throughout the world. Then I'll get into this operational concepts. Then how the level of service is estimated for a particular case. And finally, I'll go with a small numerical problem in which how a particular case in which a change in system bring about the level of service in the public transit. Now, if you take transit modes, especially we are having bus transit, then you are having demand responsive transit, then you are having van pool, then you are having rail transit, you are having automated guideway transit, then you are having funicular inclines like that. So let us see each one by one. So you are having bus transit of these different types or more you may have seen. So starting with low floor buses, you are having AC buses. Now once you see the geometry of this, you can see that the passenger capacity of these different buses are different. Another important parameter is their operational parameters, mainly its speed. Because these parameters will decide the number of passengers which can be transferred through a particular point. Another one is demand responsive transit. In India, we don't have this concept. So this will not have any fixed route. this route will be varied based on the demand, and they provide these services within a particular route. Another one is van pool. This is somewhat similar to carpooling. There is a group of people who are going to from a particular origin to a particular destination. They used to use a common mode. Another thing is mass transit, mainly light rail transit. The photo, whatever I have shown, is with respect to Kolkata Metro. So you can see how much number of passengers can be transferred from a particular origin to a particular destination. Second one, you all are aware of that, it is metro services. Another one is automated and guideway traffic. You have different types. These are some of the photos in Miami, New York, Memphis, like that. Now, all these transit services, what I am showing, has mainly three components. One is passenger load, second one is speed, and another one is reliability. So all these things I will discuss what it is in detail. Because to analyze a system, suppose you had developed a particular transit system in a particular route, you want to assess whether it is working properly. So how will you do it? So those things will be discussed through this analysis of capacity. Or if you are implementing some changes in a particular system, how these changes will affect your transit capacity or level of service of that. This is another one. This is mainly used in hilly terrain where passengers has to be transported to an inclined surface. This is cable cars in Boston and San Francisco. And finally, the other transport which is used in urban where water bodies are nearby is ferry transit. Now, let us see with respect to the operational concepts of a particular transit system. Now, the most important parameters with respect to operational concepts are capacity, speed, and reliability. In addition to that, other parameters which contribute to the operational performance are passenger demand characteristics, then dwell time, then the operative environment, the environment and deliver, and stop and station characteristics. Now we will see one by one definition of this. Now, what is person capacity? Person's capacity is defined as, suppose if you are having a particular, route. So this is a route. It is the number of passengers which can be transferred through a particular point under a specified operating conditions without unreasonable delay, hazard, or with reasonable certainty. So these points are critical with respect to capacity. That is, you have to specify what is operating conditions. Then you have to specify what should be the delay. You have to specify what is a hazard or restriction and what is the certainty what you have to provide. Now, operating conditions means you can have different types of roads. You are having 2-lane, you are having 4-lane roads or dedicated lanes. Those are operating conditions. Without unreasonable delay means this delay varies with respect to land use. Suppose if you are having a particular road and this road has having so many schools, one school here, another school like this. So what happen is the delay will be varying when you compare with other place. We're having same operating condition and other parameters like hazard, reasonable uncertainty. So once you define the capacity, you have to mention what should be the delay for a particular network, what you are defining. Another one is hazard or restriction, means if you take a bus, a normal bus, seating capacity may go up to something around 45 to 50, and standing maybe half of that, maybe 20, 25. But the thing is, if you see the volume of the bus, still you can put more number of people, but that is not as per standards. So some comfort level has to be mentioned. That has to be mentioned with respect to this hazard. And certainty means what is the probability that a vehicle will come, or what is the frequency or with which vehicle will arrive at a particular point continuously for a period of time. So these four parameters has to be defined first to define the capacity. Now, if you see the person's capacity, it is a product of two things. One is vehicle passenger capacity and number of vehicles, that is total number of buses which are moving in that particular route, or total number of transit. It can be a bus, it can be a metro. So total number of vehicles multiplied with individual capacity will give the number of persons which can pass through a particular point. Now, this is what I told previously, that it depends on given locations, then operating conditions. So if you take one parameters, maybe operating conditions, this hazard and certainty, if you keep, maybe some places you will have some unreasonable delay, just like I told you, some schools land use changes, so the boarding and the lighting time will be varying. So these factors has to be first fixed to fit the capacity of a transit system. Now, with respect to this vehicle capacity, it is the number of vehicles that generally we used to take with respect to traffic volume count survey. What is the number of vehicles which can pass through a particular point in a given interval of time? So in our case, it is a number of vehicles is number of transit vehicles, whether it is buses, trains, or other vessels. Now, we will take what are the factors on which this passenger capacity depends. Generally, the unit will be number of passengers per hour. Now, it depends on two, whatever I told is vehicle passenger capacity, that is, what is the number of passengers can be accommodated in a vehicle. Then number of vehicles which are moving, transit vehicles, which are moving in a particular route. And if you take within these vehicles, this depends upon how many number of standing people are there, how many number of units vehicles are there. For example, if you are having a metro, you will maybe having 2 or 3 cars. So that decide number of passengers which can be accommodated in that service. Another one is seats and wheelchairs. Now, if we include this wheelchair, what happens is the movement of passengers will be difficult. Again, the space will get reduced. Another important parameter is which decide the seats and standees is the size and layout. So previously I have shown some 3 or 4 pictures of bus transit. If you go inside this bus, the seating arrangement of this bus is itself is different. So whatever number of passengers which you can adopt in that also varies. And this finally depends on passenger demand and its variability and onboard crowding. Finally, it will get into the land use characteristics of that particular link or network you are studying. Now, with respect to this bus vehicle capacity or number of vehicles transit which are moving in a particular route, it depends upon the dwell time. Dwell time is nothing but the time spent during boarding LIT. So, and it depends on the guideway type, whether signal controls are there like that. Now, another important factors which depend on the capacity of transit is the speed. Speed is nothing but we have studied different types of speed in the traffic. So it is nothing but the distance traveled by time. That depends upon the travel time rates. That is, if you take a particular link, within that link, what is the travel time per miles or per kilometers? This depends, the travel time depends upon delay, then passenger service timing and running time. Now, this running time depends upon the guideway design and vehicle speed. Suppose if you are having a old bus, the running time will be different. Suppose if we take the case of BRTS, Bus Rapid Transit System, you are providing a separate way for that. So the running time is different. Now, if you take with respect to delay, you see this parameter delay. This depends upon transit preferential treatment. Means what I told BRTS, what you are giving is you are giving a dedicated lane. So delay will be less. Another one is modal interactions. Modal interaction means within a road, you are having different types of vehicles. If you take the case of bus transit, in the peak hour, it has to interact with some other vehicles, maybe cars, two-wheelers, like that. Then traffic signals, another thing. So all these factors will contribute some amount of delay. And another one is acceleration and deceleration characteristics of the vehicle. Finally, these all come to the case of number of stops. If number of stops are more, then what happens is the acceleration and deceleration characteristics also will be affecting your speed. So when you look into the micro level, you can see that small parameters will contribute some small change in the speed, which will finally result in the variation of capacity of level of service of your transit. Now, this is a typical bar chart showing the speed variation of different types of commuters. Now, the x-axis, the unit is in miles per hour because taken from a US manual. So you can see that the variation of speed within transit system itself. For example, if I take commuter lane rails, the speed variation is from 25 to 45 miles per hour. Within commuter rail itself, there is a variation in speed. So this also will contribute some amount of variation in the capacity or movement of traffic in passenger traffic in a particular link. Another most important part is reliability. This is common in our roadways. Reliability, if you define as, it is the confidence in which a bus will come to a particular stop at a particular time. Now this varies with vehicle quality or vehicle age. Now in Bangalore, what we have observed is, if you want to move from one point to another, if you go in Volvo bus, you can reach very fast compared to normal bus. Normal bus, it is old, and this acceleration and deceleration characteristics is different. If you fix a time of 9:20, it may reach around 9:25 or 9:30. Another one is maintenance. If some vehicle breakdown is there, then what happens is the vehicle will not be able to keep up the time. Another one is driver availability, absence of drivers. All these things will contribute some point of uncertainty in movement of passengers within a bus. Another external factors is environmental, there is rainfall is there, or extreme heat. Others with respect to traffic signals. Another is with respect to passengers. Suppose if a bus is moving to a, please unmute your mic. Another is with respect to passengers is, suppose if if your bus moves through a hospital location. So what happen is, there may be lot of patients will be there. So their boarding and alighting characteristics will be different. So what happen is, it will contribute some amount of variation in the schedule of the bus. Another one is this transit passenger demand patterns. Now you can see from this graph the variation of daily boardings in a particular day. You can see some point it is more, some point it is less. So these will contribute some variation in the dwell time of passengers. Another one is peak hour demand variation. So within the peak hour, if you take 15-minute peak, you can see that it is slightly higher. This passenger variation also will contribute to the passenger load in a particular route. And I told with respect to dwell time, it is nothing but the time spent at a stop or station, mainly for the movement of passengers. So this depends upon passenger boarding and alighting. This definitely, if number of boardings and alighting is there, what happen is dwell time will increase, and finally it will affect the reliability. Finally, it will affect the capacity of that system. Another one is with respect to fare payment. So in India, we have mainly two methods. One is a ticket will be served, and another one is through a machine. If you have some other method, then what happens is this passenger interaction within the bus also varies. That also will affect some that also will affect this travel time of particular route. Another one is with respect to vehicle type and size. Now, if vehicle size is more and its doors are open, what happens is it will give less time for passengers to board and alight. Another one is within the vehicle circulation. If more space are there within the bus, so the movement of passenger during boarding and alight will also be help in decreasing the travel time. Now, this is a particular graph which shows the variation of dwell time with respect to capacity of the bus. Now, if I take a particular point, 45 seconds, now you can see that the capacity is somewhere around 40, 48, 49%. Now, if you see the dwell time is slightly reduced to 35 seconds, you can see an increase of capacity 10%. That is, it goes something around 60%. Another one is operating environment. Now you are having the transit moving in different operating environment. One is mixed traffic. Best example is our public transport bus. You can see that bus is moving with different types of traffic. For example, cars, two-wheelers, autos, even bullock carts also is there. Another one is semi-exclusive or lane partially reserved for transit use. For example, if you take the example of light rail transit system, for example, trams in Kolkata, it is a semi-exclusive lane. The thing is, it is moving with mixed traffic, but it is interacting with some amount of vehicles also. Another one is exclusive lane, but you are sharing a portion of right of way. For example, your bus rapid transit system, that is BRTS, what you are doing is within the road, you are providing a particular lane only for bus. Another one is grade separated, which is best example is your metro. What you are doing is you are taking the entire traffic away from mixed traffic and a dedicated facility is being provided. This also affects your capacity, and you can see that from mixed traffic to grade separator, you can see the capacity increases drastically, but the cost also increases. These are some comparison of mixed traffic, the guideway type with respect to traffic control, traffic delay, and speed restrictions. Now, if you see mixed traffic, you can see that the speed is mainly regulated by other vehicles in the traffic. Whereas if you come to grade separated, the speed is not affected by any other traffic. It is given by you will go with respect to design speed. Even though if you provide design speed with respect to geometrics, but what happens is you will not be able to achieve due to the influence of other vehicles in the traffic, in mixed traffic case. So same thing varies with other guideway types also. In addition to that, there will be some interactions with bicyclists and pedestrians also. Now, the presence of this bicyclist, this will delay the buses entering the roadway from the stops. Similar to that with respect to pedestrians also. So this will also obstruct the movement of transit. Another important factor which decide the capacities, one is vehicle platform inductance. Now, if you are provide a low floor type bus, what happens is the boarding and alighting time you can decrease. But with respect to geometry, there are some restrictions. Another one is with respect to vehicle characteristics. As I already told, with respect to type of vehicles, the capacity also varies. Another is fare collection and stop spacing. If number of stops are more, the boarding and alighting also will be more. So this also will affect the capacity in a particular route. There are two types of transit quality service. Here mainly I am discussing with respect to fixed route quality service. Another one is demand route quality service system, but since that is not operational in our country, I am explaining with respect to fixed route quality service. So here the quality service mainly depends on the service frequency. Service frequency means number of vehicles which are moving or the headway between the vehicles. Another one is hours of service. Hours of service means during, suppose how much time the service is operated, whether it is morning 6 to evening 6 or 24 hours it is there. So these are the two parameters which depends on the fixed route quality service. One is service frequency and another one is hours of service. Now these are the main three measures which we have to analyze for a fixed transit. One is passenger loads, second one is reliability, and third one is travel time speed. Passenger loads, what I told is loading standards. That is, in a network, there will be congested part also, uncongested part also. So what is the maximum number of passengers who can be transported through a particular route under ideal conditions? Reliability, as I already told, it is a confidence in which a particular schedule will perform properly. Another one is travel time. Travel time, it depends on various factors, number of stops, types of vehicles, type of routes, etc. Now, coming to the concept of level of service. So, I am explaining with the level of service for a bus transit facility. So, these are some empirical equations which has explained in transit capacity manual. So first most important part is transit weight ride score. So transit weight ride score is nothing but it depends on headway factors and perceived travel time factors. Now, if you take headway factors, it is nothing but the number of vehicles or transit which is moving through a particular. Now, if you see that equation, it is the form of an exponential function. That is negative exponential function. And they have developed an empirical equation for that. And this is shown here. Another parameters is perceived travel time factor. So perceived travel time factors, it has various components. One is relating to passenger loads. Another one is with respect to speed. Another one with respect to reliability. And another one with respect to stop amenities. Now we will see each of these parameters what it is. So it depends on ridership elasticity. Ridership elasticity is nothing but the variation of riders or passengers in a particular route. They have taken based on weight. It is, if you take in a metropolitan area, it is 6, and if it is more, suppose if it is other than CBD, you can take 4. The unit is minutes per mile. So it is nothing but in a particular route, if you take per mile or per kilometer to travel, how much time you require. For example, if you take SITs, it shows that in a CBD areas, you take something around 6 minutes to travel 1 mile. Or if you go outside a CBD area, it is something around, you take 4 minutes to travel 1 mile distance. Another factor is perceived travel time rate. It is with respect to the excess waiting time. You can see in previous equation TPTT. It depends on FPL. FPL is passenger load waiting factors. So you can see the various parameters which has been done empirically to arrive with this factor. One is average passenger trip length, that is in miles. Suppose 100 passengers are there and their average total trip length is something around 1000 miles. 1000 by 100, which is 10 miles, is the average passenger trip length. Another one is perceived amenity time rate. Suppose if you are providing some facilities like benches, shelters, that also some factor has been arrived. You can see that equation, previous equation, TAT. So it depends on number of passenger, that is passenger load LPT, and shelters and benches available. So PSH is a portions of stops with shelters and PB is with benches. Another important parameter is pedestrian environmental score. So this depends upon cross section of the road, motorized vehicle adjustment factor, that is number of vehicles. Another one is motorized speed adjustment factor and width of road. Width itself, two parts is effective width and width with respect to bicycle line and shoulder. Another one is portions of on-street parking also has been included, that is PPK. So what I want to tell is this mathematical model has been developed for US condition. So in Indian conditions, each parameters, what I feel is you can make one research topic with respect to that. Finally, it can be contributed to the development of transit capacity within our country. Now you can see that they have put a lot of effort to bring out this manual, and all the parameters as covered with respect to transit. These are another factors which we have already explained. Finally, they have arrived with a score which is called level of service score, which is represented from A to F, and the values varies from 2 to 5. Less than 2, it shows a good level of service, and greater than 5, it shows a very bad level of service. Now we will do a small numerical problems with respect to this. So the situation is this: you have an arterial street which run through an all commercial district of a city, which is a couple of miles from the city center. So as part of planning, they want to improve the transportation options in the area by changing the available right of way for different modes. So they have considered the level of service, that is multimodal level of service, these performance measures, to analyze all these alternatives. The configuration of this is a 4-lane street with on-street parking and 8 feet sidewalk on both sides. And they have buildings to the edge of sidewalk, and 3 alternatives has been analyzed. So first alternative 1 is to replace the on-street parking with bicycle lanes and wider sidewalks. Alternative 2 is to reduce the roadway to 1 travel lane in each directions, and you have to provide a landscape median. And alternate 3 is to create part-time bus lanes and widen the sidewalks and plant street trees. So all these options I have shown pictorially, since this has been taken from transit capacity manual. So the direction of transfers is little different from our country. So you can see existing conditions, you are having a parking lane here, this point, and 2 lanes. In alternative lane, what they have considered is they have reduced this parking lane into a cycle track and increase the width of the road. In other case, what they have done is they have provided a wide median here and exclusive movement for different traffic. Third option, they have provided an exclusive right turn lane in this, and they have provided some landscaping in this area. Now let us see how these factors will contribute to the level of service of our transit system. So the question is, now what is each alternative transit level of service during weekday peak hour? That is, you are having one base conditions and you have proposed 3 alternatives, and what will be the level of service for these 3 alternatives? So the facts, or what are the data that they have collected? The bus service was provided every 15 minutes. Bus stops were located around 750 feet apart. Then the frequency of buses for all these alternative is same. There is 4 buses per hour. Thus, for each alternative, there is a slight variation in bus speed. The load factor, which is nothing but number of passengers per seat or number of passengers per bus, is almost same. Excess waiting time is slightly different for alternative 3. And alternative 3, you are provided some shelter and benches. Why? Because you have provided some landscaping there. Then the geometric factors, sidewalk width, then sidewalk buffer, any extra distance, and percentage segment which is utilized by parking. Then number of lanes by directions and vehicles per hour, total flow in this, and motor vehicle speed of this average speed as we show. Now with this, we will go with respect to each steps. So step 1, you find out the transit weight ride score. So first you have to find out your FH, that is your headway factor. And once you substitute F, which is nothing but your headway, which is 4, so you will get a factor of 2.8. Means that this provide a ridership of 2 times the existing ridership. Another one is perceived travel time factor. To find perceived travel time factor, you have to find various parameters. In that, one is passenger load factor, and this is estimated using that empirical equation. Since the passenger load is whatever we have mentioned is 1.1 passengers per seat, so we have to use that third equation, 1 plus LF greater than 1. So load factor comes around a value 1.41. And since there is no benches in the first case and shelter in the first phase, the values of TAT will be 0. Substituting this, the perceived travel time factor, you will get 13.8 minutes per mile. Means for traveling 1 mile in that particular condition, that is base condition, you require something around 13.8 minutes. Now, the perceived travel time factor for that base condition, while substituting the previous values in the equation, you will get a value something around 0.64. So finally, your transit weight ride score is nothing, the multiplication of FH and FTT. So you will get a value of 1.79. Now we will analyze these 3 cases with respect to transit weight ride score. If you take the perceived travel time rate, that is this one, you can see that in existing condition, you require 13.79 minutes to travel 1 miles. Whereas if you go with respect to alternative option 3, you require only 9.54. You require only 9.54 minutes to travel 1 mile. So same is indicated with respect to your transit wide ride score. Now, other factors to determine pedestrian environmental score, you can directly substitute in that empirical equation. You will get corresponding values. And final that empirical equation, you will get a value of minus 5.47, 1.58. Now, coming to here, last one, that pedestrian environmental score, if you take, you can see it is least for alternate 3. That is 1.16, where you have provided some amenities. Now coming to your final level of service and level of service score, you get a value of 3.56 for the first case, whereas other cases it is alternative 1 and 2 is slightly higher, whereas alternative 3 is less. So you are having a higher level of service of C you are obtained with respect to that. Now, what I want to conclude is, even though these relations are empirical, technically you are able to come up with conclusion saying that these parameters are influencing your transit capacity. Otherwise, if you want to provide some changes in the system, what we used to do is we will just go with some logical decision. Suppose if you want to provide a busway in that, we will just see whether space is available and provide the busway. But there is no technical relation between these things. So what we have analyzed is, with respect to present problem, you are having the best option as alternative 3. That is some landscaping you have to provide in the vicinity, providing a dedicated right turn lane for buses. It is the best option compared to other 3. Now with that, I have come to the end of my presentation. So what I feel is the major takeaway from this presentation is passenger loads, speed and reliability are the most important parameters of transit capacities. And the capacity estimation with respect to transit, it is not developed that much. Presently, we are designing with respect to logic, which has to be further enhanced with respect to these parameters. Thank you. So if
Thank you, Vivek sir, for your presentation. It was an awesome time we had. We learned many things. Now the platform is open for any kind of discussion, doubts, or any questions which the participants would like to ask to Vivek sir. You can kindly unmute your sounds and can have an interaction with Vivek sir.
any questions?
Anyone? Okay. I hope the presentation was so clear that no participant has anything to ask. If at all you want to contact sir, you always have his email ID and phone number, and he's always on a helping mode. I thank you, Vivek sir, for this wonderful presentation, and we hope in the future we get more to listen to you. Thank you so much.
Thank you. Thank you.
Thank you all.
Thank you.
We have a question.
Okay.
Is Priyanka online?
Okay. How can we categorize?
Yeah, how can we categorize paratransit or informal transportation in our public system? This is a question by Priyanka Priyadashini to Vivek sir.
Okay. So what she has asked is to characterize paratransit or informal transportation in our public system. So there is no special method to characterize or categorize paratransit. It is not, it is, even though it has been used in public transportation system, we can go with respect to same methods, whatever I have told, that is with respect to speed, then capacity and reliability.
Any other questions from the participants?
In extension to the same question, sir.
Yes.
I wanted to know whether we have that for informal transportation or not. Like
No.
we have share auto and share e-rickshaw and something like that. So that comes under informal?
Yes, shared transportation is there. For example, in Ola, there is an option. You have shared taxi is there. But with respect to public transportation that is owned by government, it is not there. Is that whether I answered your question?
Yes, sir. Yes, sir. Thank you.
Okay. Now another question is.
Yeah, we have a question from Dr. VK Gehlot. His question: what is the best way to select alignment for PT, any mid-sized city?
It is mainly with respect to traffic. Now, if traffic is more, what you have to do is you have to go with respect to an elevated option. For example, in Bangalore, what we have seen is we have a two-tier system. So in ground level, you are having all the cars, everything will be moving. And in the first layer, you are having public transportation, and the next layer, it is metro. So if traffic is more and width is restricted, then you have to go with different layers. Whether I have answered your question?
Yeah. Yeah, we have one more question from Ms. Vijay Lakshmi Prakash.
Okay.
Is there any code book for public transit design? That is a question from Vijay Lakshmi.
That is why I started with the first slide. In India, we don't have any code book for public transit design, but in US it is there. There is transit capacity manual. So whatever I have explained here, I have taken a small portion of that. So what I feel is, if you explore that, a lot of research can be done, and we can come up with our own transit capacity manual, which will be useful for BMTC. That is in Karnataka, it is Bangalore Metro Transport Authority, to analyze a system. Suppose in a particular route, whether how many number of buses you have to decide, whether bus and metro will work, whether number of passengers which they transit in a particular route, technically we will be able to tell. Otherwise, what we are doing is we are doing with respect to logical.
Okay. So I thank all the participants once again for having given up the time and attended the program. Let's all hope to meet tomorrow for the next speaker. Thank you, one and all. Thank you, Vivek, sir.
Thank you. Thank you. Vivek.